You ready? You ready? You ready? You ready? You ready? So yeah, let's speed this up a little bit. What are we doing? We're trying to find the volume of f of x is equal to the square root of x minus 1 when y is 0, x is 5, and it's about the x-axis. I know. Let's just stop that right there. Let's take a look at this over here. Whoa, not that. That. Because first I want to graph it. So I'm looking at the graph. Yeah. This function, boom, that's the one that we are trying to find the volume of when it's rotated about the x-axis. This is the picture of the square root of x minus 1. Yeah, because its root shifted right 1 unit, so that's right there. Bam! Why? Because it's bound below by the y-axis, and we're going to cut that off right here. Boom! So we're taking this shark fin and we spin about the x-axis, and it's going to create this little hyperbolic paraboloid. So that gives us our limits of 1 and 5, because this is x equals 5. Yeah. And then we spin it. So what's the area of a circle? Because we're making these little circular stuff. That's pi. Boom. Y, or pi x squared, pi times our function squared. That's what we're getting. Don't look at that. That's what we're getting right here. We're setting up our limits when we stick our f of x in there, take that pi out, the root gets taken care of by the square. Then we integrate each one of those pieces. That's x squared over 2 minus x. Yeah. And then fundamental theorem of calculus applies. That's what happens over here. We're evaluating upper minus lower. We do the arithmetic. We determine that yellow is not a good color for this. And it all turns out to be 8. Great. Wait. Looks like we forgot our pi. That was that pi on the outside of our integral. So I just went back and I did that. And it's all over. But the box and flower.